Oh, Margaret's here. Wonderful. So she can help me fill in any information that I'm not familiar with. So today I'm going to talk about a tool that I've been developed over the past about a year. And I received some metabase. It's a database for managing the metadata. I receive a whole bunch of the information from the metabase, and then I know R. So I have been spent about a year of time to trying to develop a tool in R that I can read directly from the Postgres, which is a metabase, read the information from the metadata, and then generate EML, which later we use for archive our data package. So this is a tool that requires two different softwares. One is a database. The one I shown here is Postgres. They don't necessarily to be a data. They don't necessarily to be a Postgres. You can use SS database, or you can potentially use even Excel with a whole bunch of different tabs on the Excel. You can do the same thing using R. So it's a database. It's just a way to for me to use for putting all the metadata together. For the R part, the code I code is everything in R, but potentially you can do this system in MATLAB, Python. They will work the same way. So it's give you a broader picture of how these things connect together. So today I want to focus two topics. One is to demonstrate the metadata storage and management using relational database. Here, I specifically mention is the Postgres data table that we put together. And I want to show you one example of the workflow from filling in the Postgres database, the tables, and to generate the EML in R. And the last step is to preview the EML document on EDI to know that, okay, we got the correct information and the EML that we want. So for the database part, the relational database, right now we call it metabase. It's just a short name for it. And thank you to Wen that in the LTR group that he originally designed these 86 tables of metabase. But by the time I receive all this table, I decide to minimize how much table I want. And I reduce to total of 3 schemas and 28 tables with only 8 tables that needed to be updated for all the data set, all the incoming data set, if you need to manage. And so I have a screenshot of the schemas that I use in the database. You can look at this like a table group. So I group the table in the different names. First, the mini metabase. This is a database that including all the metadata that's required for the EML package, for the EML document. And we also have a package management schema. We call it schema. And this is specific to EDI. So if we want to archive a data package on EDI, we need a number for it. We need an EDI number for it. We need a revision number for it. And we need a public date for it. Those are stored in the package management, which means we will change, if for time series data, we will change the package management, the revision number will not go into a mini metabase to change any of the database information there. And then the third one, this is a metabase to EML and R. This schema kind of like a mirror of the mini metabase. It's mostly for security reason, because we want to use R to read our database. For security reason, we don't want the R directly read the most important mini metabase. So we kind of make a whole bunch of copies and image over to the other one, just for security purpose. We can go down that if you're interested in how to set up that part. but essentially there are only two, the mini database and package management. So this is 7 essential tables that we need to update for any incoming data set. Those 7 tables, including the key ones, data set table. And I'm going to take you through all that later when I show you the example. I just show you the structure first here. And the second one is the data set temporal range and the keywords for that data set, the personnel for that data set, and all the methods, including sampling protocol instruction software for that data set, and also the data set site, so where the data was collected, and also the data set entity, so how many entities that go into each of the data sets. So those 7 tables, regardless what data set coming, we pretty much need to update all of those. And now I'm gonna switch to the actual database and then let you see how I play with it. So because I manage the LTR data in the inbound, so today the package, the database I show you is based on the one that I construct for the inbound. It's a slightly 2 tables less than the LTR. The LTR had already last for about 20 years, so they have a more information need to record it. So the same I should show you in the schema, and we have this mini database, and those are the table we're looking at, and the top 7 are the ones I show you, and everything below that, those are the table too, but those are more like vocabulary control table. And also we want to control different units that we can use. We want to control the different measurement scales, and we also want to control the keyword to avoid people typing ecosystem with lowercase ecosystem or uppercase ecosystem. So it's a way to control, and also have a people table here, which including all the personnel information for the entire marine biodiversity observation network project. And so I want to show you one example, and then I take you through all the information I put in those tables. So if, imagine there is a PI send me a data set called Giant Kelp, which I got it from LTR. And first I go in this on my desktop, which is actually on the server, and I create a project called 999. I give it a project number called 999, and then I put the data set in the project folder. And now next thing I normally do is I go into another previous data set I already archived, and I copy projects, the Archole, I copy method, I copy the abstract over to this project 999 because most of the things are the same. And so I just need to change the project number here. Okay, and also including this one to make it consistent. And so for the abstract, normally a PI will write an abstract about this project, or maybe I can help PI to wrap it. But for our purpose, I'm gonna just put in a short note here. So this is abstract. You can put in anything you want for the Word document. And then we close it. And then we're gonna have a method. I'm gonna delete all those from the previous project and type in any method you want. It's normally a PI will give you a method and a Word document, how they get the experiment done. And for the project, this is the Archole, which we're gonna get back that later. But only 2 things we're gonna change on here is the dataset ID. We want to type in 999 because that's how we define that project number. And then the EML document will be 999. That's all we need to change in Archole, just these two numbers. And then, okay, now we're going into this database, and then we start our data metadata input. So for our purpose, we just keep all the metadata very short and quick. Of course, you can spend more time on it, but I just want to speed through this process. So I make a copy, and then because we define that the data set number is 999, and then I'm just gonna change this kelp. It's a giant kelp, and I change the investigator into my name, not necessarily my name, someone else's name word too. The abstract, which match the abstract Word document we just changed, we just modify. And so we save this, and then we go into the next table, dataset entity, and then we add a line. So we change 999 and kelp. You can spend a lot of time to make a beautiful name on it. And it's also a CSV file, and it's a sort order number 1, and stay in the same place, no problem. Only change, this is the actual kelp file from here. So just copy the names over. Copy a name. Make sure the file name we define here is what we want. Okay, we save it. And then we go into the attribute table and take a look at it. This file. So they have about five columns, 6 columns here. So we just quickly see, this is a benefit of using the database, because I know from previous project, I have so many information already inputted, and they are actually almost the same. So I don't need to retype every single information. I can just go in and copy. For example, dates. Okay, we have a date here, and then we make a copy and change to 999, and change the column position, which is 1, and then make it into a capital. And pretty much those that stay the same. Okay, no problem. Second one, site. So we have a site that we can get it. Site ID. Okay, this is site ID. We make a copy and then change to 999. It's the second one. And then change to capital site. I think they are the site ID. It's the same thing. And then we can keep that the same, and everything else the same. Okay, great. So next one, species code, which is a taxa. So it's actually similar as this one. So make it 999. 3. This is species code, which is giant kelp. And then we can change that to taxon code. It's not assigned by any authoritative source. So we change that part, and everything else is stay the same. Okay, and next one, count. So we have a count here. Perfect. So add 1, change 999, number 4 column, and change to count. Number of kelp. Change this so we know it's the kelp plant. This thing we want to change because it should be an integer. And ratio, and this should be number, no problem, 1, and this is an integer. See here, from previous project, it has a missing value code, and in this data set, it doesn't have any missing value. So we don't have to have this one. So we change to non-value. And then next one, area. Oh, wonderful. we got another one here. 999 and 5. And this is the area. So the area covered by survey. It should be integer choose because this is only the 20 square meter survey. So we take a look at units, square meter, which is correct. And this also changed to integer. And the last one, scientific name. Okay, we can have a search function. Scientific name. So find it. Oh yeah, here's a scientific name. So add 1 and change it to the number 6. The taxon name. Okay, great. It's a string. It's a nominal text. Okay, we got everything down here. Save it and sort it. So everything's here. 1, 2, 3, 4, 5, 6 column. That's all we get. And wonderful. We're done with this part. And now we go down to keyword. And as I know, this project similar as some of the previous projects, so we can use some of the similar keywords. Of course, you will discuss with the PI, and some of the LTER involve more sophisticated consideration of what kind of keyword put in it. But for now, we can get some easy ones. It was survey in the swath, and then I know it's a population abundance. And I also know it has a taxon scientific name in it. So we're going to make a copy of this. We're going to make a copy of this. And so we get to 999. Just change it to 999. Okay, we save. This is a keyword we have. Method. Even easier for this project. And make a copy. And 999. Data set, it's the effective range for the data for the method. Sometimes some data set come with 5 or 6 different methods, each method for different entities in the data package. Then we can have maybe 5 or 6 rows in this table. But this time we only have 1, which including the method 999. Yes, and so this is the one that we use. We just added before we go into this database. It's matching the same method, the Word document. So we save it. Personnel for here. So I saw my name here. Add it 999, and I'm the second one. So who is the first one? Because it's for organization, so every time I put the organization's name as the first creator. That was just a rule in the mBond setting. And so they are the first creator, and I'm the second one. So when we sort it, say, okay, we got mBond as an organization and got my name as creator. Site. Because this had been surveyed inside the channel island, which is the same as the other data set and use the same area. But sometimes if we want to go in more detail, like for example, this project, 1005, they actually has different dots for each of the sampling point. But now for time saving purpose, I'm gonna put a polygon in it, just including the whole area instead of putting single dots for this project. And so 999, it will be the same. It's a near shore reef for Santa Barbara Channel in Channel Island in California. And this is a polygon range that including entire 11 site survey in this data set. And the temporal range that I already took a look, it was in 2008 2008 January 3rd until 2018. They just surveyed last month. Okay, great. That's all the information we need to put in the database. And we're done. And so we close this, and then we get into the Archole. This is how much line of Archole you need to run for this setup. So we highlight the Archole, and then we'll click. Oh, before we do that, we're going to run into one issue with this. Because we need to actually create email document for EDI archive. So we did need a different information in the package management to specify the EDI number for it. So we go back here and then look for the package management schema. Go into table and update this one. So this one, I did one yesterday and then make up a number EDI 117. And revision 1 with a giant kelp. And the date received on that day right now is draft format. And this is what it staying in the project.999 folder. And then we have public day today. Make it today. Okay, so we have all the information here. And now we go back here, make sure we run the code. This data set quite big, take a while to load. Okay, great. So for the EML validation, we don't have any error. So at least from the R standpoint, when they check the validation, everything looks great. Now we go back to the folder of the project 999. Right now, this XML 999 EML file pop up. This is generated using this Archole. So now we take a look at this using a preview function. Let's see what's in there. Bingo, we done. This is the process. So I show you a workflow from inputting the metadata in the database and then using Archole about that 10 lines to generate EML document and spit out this EML document that you can use in preview from the EDI website to look at it. If the information is complete, things look good to me. Keywords, only 3 keywords, has a method document as a placeholder. It's people and organization. The SBC mBond is the first one. I'm the second one. And it has a temporal coverage about the area. So we took about 20 minutes to work through this. But as you know, there are a lot more complicated things behind that. So what is the things behind that? Let's back up here. So for the Archole you see, there are 3 functions behind that. I can pull out later very quick. But because each of the function that I code accommodate all the needs, that's putting all the metadata piece together into an EML document and write it in an XML format. So that's the function behind it. But we don't need to change that. I never even need to change that over past about hundreds data set archive. So this is great. So only thing you need to change in the Archole is really just that project ID number. And there are 3 functions run behind that. One function is read the metadata from the R. The other function is construct a data table child node in the EML document, which is reading all the attribute tables and then put it together as a data table child node. And the last function is we're putting all the other pieces for the data set tree together, including the whole EML. And so there are so many remaining questions, I'm sure. what's the constraints and controls in the relational database that not allow user to put in the wrong thing. Those will be a separate talk, or we can talk in person after this meeting, because I did set up so many constraints in the relational database that now allow you to put in any wrong information. Even you may be a brand new user, but you put in the wrong thing, a pop-up error message that are not allowed to save it. And the next one, the script and R functions. I share that on GitHub. So if you like to download it and use it, try out in your system, welcome to do so. And I'm happy to help you modify some of the R function to accommodate your needs. And some of a boilerplate thing for each of the project. Those are embedded in our Archole thing. For each project, it don't normally change. For example, the project tree doesn't normally change. But some other information like the metadata input, they directly read from the database, which is easy to control in R. And so I want to acknowledge the 3 LTR site have been helping me a lot on getting these workflows through. And the SBC LTR, Monterey LTR, both Margaret and Gasto, that have been constantly guiding me through the whole process and help me to build a better database for it. And I also wrote a database article for it. So if you want to read through it, this is the link. And also the R function package on GitHub. And this is the location. So you're welcome to go in and download and send me an email if you need more information or if you're not clear about how that was done. So now my demonstration, before it's totally done, show you 3 more things. The GitHub package thing. So I keep it here. So those are the 3 codes. And I give you, this is Postgres, which means the Archole reading the Postgres table through this only about 15 lines of function. And we also have, this is the data table function that I called, that read the data table, the attribute table, and then has the empty check and has the file size detection and putting all the physical attribute together. And if it's other format, it can recognize by reading one of the metadata cells. And the last one is the dataset function, which is putting everything together and form a EML document. So the dataset table, we read it from previous code, and then we have a creator section, and we have a method section reading the method, the Word document. And if there's a protocol, we need to input it. If there's an instrument, we want to put it in. And then we combine all the methods together. And we have an reading abstract document, and then find out what's the temporal coverage, the whole spatial extent is this part. And then we also figuring out reading the keywords from the file. And this is the last bit, putting all the title, show name, creator, part data, intellectual rights, and everything together into the last EML file. And so that's all the 3 functions. It takes probably more than a couple hours to go through line by line. So I stop here, and you're welcome to download and check out it yourself and ask me questions if you need. Okay, I think my demonstration, that's it. And I have the slides for the metadata table structure that I will keep it in the slide. And if you like, you can go through it also. And also the screenshot of each tables that you will see when you're inputting the metadata into the database. Okay, let's get back to this part. Any questions?
Can I ask a question? Oh, actually, I want to make a comment. You said that when you were showing the schemas in the database, there was one called MB to EML _ R. And I don't recall you saying it, but I think it's an important point to make that that schema is the abstraction layer between the tables. All the only thing that's in that schema are views. And
Right.
they are the abstraction between the tables themselves and the R code. So that if they actually, it works really well to organize it that way, because if you need to make a change to the backend table, if you don't have to change the R code, because the R code doesn't actually query the tables themselves, all you need to do then is update the view so that it still can be queried by the R code.
Oh yeah, so if you go in depth about this MB to EML R, so this schema are used for the R purpose. If we decide to archive the data, for example, in ORDAP, they may require different column names, different coding system for it, but they may not directly recognize the column name from the mini database, but we will change the column names into different schema and then let them read it. So we never need to change anything in the mini database. We will change how we set that in this view table. So there are 10 view tables, which means we extract the information from the dataset table, which is quite similar. Let's take a look at it. So it's similar as the dataset table, has a dataset ID, has EDI numbers in it, has a title which got from the dataset table, and has abstract, has a project date, update date, and then some show name. So it put in information in some different orders for the R code, a common day R codes need. Yeah, so this part, yes, if we construct the table using the metabase, using R to read it, we want to have those views. For security reason, also for better R code to recognize the column name. Yeah. Thank you, Margaret.
John posted a question in the web window, in the chat window. Can you comment a bit on the conversion of Word to EML? He tends to find that Word loves to add all sorts of odd characters, even open quotes are one character, closed quotes another. And
let me take a look at the comment.
Maybe, Lee, if you don't want to show your files any longer, you could unshare the screen. Then we can see all the participants.
Let me unshare it.
You just click on the share screen button.
Oh, right. Stop sharing.
Mm-hmm. Thank you.
Okay, now we're back to this. Great. Conversion of Word to EML.
I think John is asking how you handle the odd characters that, because Microsoft uses a different character set, does not use UTF-8, at least doesn't use it completely according to the rules.
Okay, that part, somehow lucky enough, honestly, I never dig into that, how to even control all those weird quote thing, but I never have a problem that's, I only use one line of R code, and that was a prefix R code thing in the R EML package. And I didn't go out of my way to figure out the detail of that, because I think for now, over the past year, I never run into that issues about the weird coding thing. Maybe you can send it to me. I can play around it to see that. I don't have experience on the weird quote in the Word document.
Yeah, the things that tend to drive me nuts are things where people will do degrees.
Uh-huh.
And then the fact that the open quotes and the closed quotes come out as these bizarre things. And anyway, it may be that the function that you're using in R is smart enough to take care of all of that, but it causes me considerable headaches, because I have some things that I filter my document, the things people give me, but a lot of times if somebody has cut and pasted something from Word, you got trouble.
So
yeah.
Can I make a comment? John, and a couple of us have been playing around with Word docs as part of the EML 2.2 development. And a few things the EML package for reading Word docs has no problem with. That would be I guess it's the EML-R, the R Open Science package. Even things like equations, it can put them in, turns them into, I guess it's LaTeX. I'm not even quite sure, I don't remember. But I think it doesn't handle things like open quotes, close quotes. That was one, and I think that's one of the main problem I know of with them is that one half of those quotes I think is actually an invalid character. It's a reserved character in UTF-16. I think that's what the problem is. But Microsoft has chosen to just use it anyway.
Yeah.
Doesn't email with anybody.
So I just add in a couple of things. Yeah, last time when I put the equation into the Word file, there's no problem showing up. It's perfectly. And the degrees, any other mu, this kind of weird character that's not very common, but as long as they can put it into the Word file, somehow the EML package can always read it and can display it perfectly. So I haven't run into any issue with that yet.
Thanks.
Mm-hmm. Okay, so there's another question about, does this use the EML package? Yes, I actually built upon beyond that package. All my function, this Open Science EML package was the base. And then all my function built, it's beyond that because I need to read the database, relational database. And also I want to be able to detect, for example, if there's a protocol, so we add a protocol link. If there's no protocol, then we get rid of that protocol windows in the EML. We get rid of that child nodes in the EML document. And also to detect if there's a point for the site. So when you show up in the EML preview, it show up as a dot. If there's a polygon, then it show up as a polygon. So the R function I built is making more of a detective function as what this package looks like. And if there's a data table, then it has to have an attribute go with the data table. And if it's other entity, then it skips the data table entirely. And also able to detect, for example, sometimes we have a definition for each of the columns. Like, for example, we have 11 sites. So all those site codes are only 4 letters. So what those 4 letters actually mean. And so we have those code definition detection. So if they detect this column has a separate code definition, then you go into the code definition table to read all the definition and put it into the EML file. So the function I built has more to do with how to gathering the information from the metadata table to put together, which the R package, the EML Open Science EML package, was original build is like you put in actual a text and a quote for each of the variables. If you attend some of the Collins early webinar about it, it's every information, the metadata, you put in the quote, then you assign to a variable, and then they put those information together. So it was simple versions. EML package is simple version. It's putting text together directly. And the version I have is building a whole bunch of functions to detect what information you did or did not put into the metabase.
So as new versions of EML come out, I presume new versions of the EML package for R will come out. How will you keep what you're doing in sync with these next generations that come out?
See, next generation come out. When I build this function, I actually use the first version of the EML package. Now they actually already upgrade like twice already, and my code never break. That was the cool part. And of course, the new EML come out, the 2.2. I think I did need to modify that function a little bit to accommodate more needs. For example, they have a more text in it. So maybe in the metadatabase, I need to somehow tell the Archole, say there will be a text table go with it. So it need to accommodate additional information for the EML 2.2.
So do you see what you've developed as purely, I should say, starting as a community resource for all of us LTR information manager type folks? Or is your GitHub repository first and foremost there to support your work? And if it happens to help other people, great. But you're not going to go in there and add something for tax ID if your investigators don't need it.
Let's see how we should adjust that. First, I want this package to be most applicable to all the other projects as possible. So I do have that intention that I like to contribute this to a wider scope of projects or the LTR groups. In terms of how much time I will put into it, I guess that will depend on how much time I will have down the road. Whether, for sure, I want to, when the new EML comes out, I do want to spend time on it. But if you ask me next version or some additional other attributes that maybe we don't need it at all or something, for myself purpose, I may not need it. But if someone pop up, we want to form a group that we want to get that solved in a package, I'll be happy to be part of that to just make that function work. It shouldn't take too much time, I think. Yes, Margaret.
It seems to me that in general, a lot of groups have the same or very similar sets of priorities for what kind of material belongs in data sets. And I think Li Kuei didn't mention, I don't think, that this system of R and Postgres, we're actually using it for two different projects. We're using it for an LTER, all the LTR data sets, and also for a marine bond, a biodiversity observation network. And that project in particular needs to have taxon IDs. I mean, that's one of the examples that you brought up, Tim. But so the model can certainly handle it, and we actually have a need for it already in another project. But my main point is that if these communities all have very similar recommendations, then probably any of the models that are intended to support those should have all that material in them. So what benefits one benefits everyone. So I think the short answer is sure. But yeah, how much work that actually is, Li Kuei's right to be.
We will see by the time we get there.
Well, if it benefits all, then maybe all can contribute.
Yeah.
Yeah, we have so many R experts here to form a group for 1 month to get that one piece of code done. I think that's reasonable.
So should we look into moving this to a different repository rather than an individual's, maybe to the EDI repository or to LTER? That would be one way.
Actually, maybe Colin would like to talk about the code repository, so it would.
Yeah, I mean, I think it's probably fine to be under Lee, to have it on your personal GitHub. I mean, people can collaborate with you in that space. But yeah, what Suzanne just mentioned, we're setting up this information management code registry where software related to information management tasks will be registered with some metadata. So it'll be kind of like a one-stop shop for well, hopefully, eventually, all your information management needs. So that would be a good place to register, just to make it discoverable. Among other things, through EDI, we can advertise, or we will. We'll post this and others as services that are available for people to use, or not services, but software products. But yeah, that's something we're going to be standing up here soon. But yeah, some very useful tools you're presenting here today, Lee. Thanks a lot.
I'm happy to help.
Oh no, Margaret had, no. Okay, there is a chat conversation going on. First, Tim had a question. So what would be different for describing something other than a data table, like a binary file? And then Margaret posted her answer. Maybe you can see it, Margaret. I don't know.
Yes, the answer is yes. That would be another entity, and then it's basically all the same top high-level information for the entity, but
I can show you.
there's no table. There's no attribute descriptions for another entity. The other things we don't have every entity that EML has available covered. We don't have any experience with raster or vector. But I think the other two would be covered, are very similar to data table and other entity, so they would be, we could add them in.
Yes, so in one of the table called dataset entity, we have a column that you either put in data table or you put in other entity. If it's other entity, then the Archole recognize that and then put it into the other entity for that entity row. So Archole accommodate that, and the mini metabase accommodate that too.
Are there, another? Thanks, Tim says.
I should just unmute myself and say thanks.
Are there any other questions or comments?
Are there any other LTR sites that are using this mini metabase? I thought NES was looking into it for a while.
NES is here, and we are very interested in this presentation and plan to contact Lee afterwards. Thanks so much.
You're welcome, anytime.
From my point of view, I used a larger version of Metabase before Lee started with the project, and her streamlining of the schema and the code, I think, is really a great improvement. We just found as we started using Metabase that there were a lot of tables that Wade had put in the original that if you aren't going to have if you wanted the database to be able to drive a lot of other functions like project management and many other things, those tables will come in handy. But those weren't going to be part of the scope of what we were going to use it for. So we found that we hadn't populated any of them. And there are a few that we actually have started to add on to later. We've started using the project trees that are in Metabase for project level descriptions for the web. And we also use, I think we might end up using some of the biblio functions, but it kind of depends on what the network decides it wants out of bibliography material. We need to make some changes to what we're doing. I don't know how we're going to go yet. But for a new site, I think having a really streamlined schema and some simple code makes a lot of sense as a place to start because you can add to it pretty easily. And if you're adding to it in a group of 4 or 5 sites, I think in the long run, it will make those sites their approach will be very similar and easier to translate to other groups.